Okay, you guys, today we're doing lesson 4.9. This has to do with the relationships among the angles and the sides of a triangle. That's basically what we're doing today. We are going to be talking about the triangle inequality theorem and the SAS inequality theorem and its converse. All right. Woo-wee. This is something you guys haven't seen in a while. Okay, solve the following inequalities. Inequality is when you say, okay, is it greater than, less than, or equal to? That's what that symbol means. That's why you don't say solve the following equations, because they are not equal, okay? They are unequal, okay, or greater than, less than, or equal to. That's what that means, okay? Now, the good thing is that you work them exactly like you would an equation, okay? So when you take a look at this first one, we know we're trying to solve for x, so you kind of think of that as your equal sign. So you'd add 9 to both sides, and that gives you 4x is less than or equal to 28. Divide by 4, and x is less than or equal to 7. All right, number 2. Let's see, we are going to solve for x, so I would subtract 13 on both sides, and that's going to give me negative 18 is greater than negative 2x. Divide both sides by negative 2. Woo! All right, now, when you divide, when you're trying to solve for your variable here and you divide by negative, this sign gets switched. That's a rule that hopefully you guys remembered, okay? So it's going to become 9 is less than x. You might want to put a little star by that if you want to in your notes, just to help you remember that when you divide by a negative, that you flip the sign, okay? All right, so let's move on to number 3. 2/3 x plus 1 is greater than or equal to 13. All right, so I'm going to subtract 1 on both sides, and that's going to give me 2/3 x is greater than or equal to 12. Okay, I need to get that x by itself. Now you got negative 2/3. You can't like divide, okay? I don't know if you remember how to handle it when you have a fraction with your variable, but the way that you handle that is you multiply by the reciprocal, because that will cancel out, and now I have my variable isolated. So both sides gets multiplied by the reciprocal, okay? And so then that leaves me with x is greater than or equal to 12 times 3 over 2 is equal to 18. Okay, and the last one, number 4. Now, don't panic just because this one has 2 sets of signs, okay? Don't freak out by that. But what you're going to do is you're trying to get that x by itself. So what you do is you kind of do both sides. You're going to add 1 here to cancel out, okay? But then you add 1 over here, and you add 1 over here, okay? And that gives you negative 6 is less than 3x is less than 15. And then what you do is you're still going to divide by 3, okay? But that means you divide this one by 3 and you divide this one by 3. Man, doing lots of algebra. I hope you guys remember this part, okay? And then this leaves me with negative 2 is less than x is less than 5. This is where you just have a range, okay? That's where there's more than one right answer, okay? And sometimes it deals like that when you have inequalities, and that just means x is going to be greater than negative 2, but it's going to be less than 5. So your answer is somewhere in between those two, okay? All right, now, comparing angles and sides. Look at the triangle below. The sides of the triangle are given. Can you determine which angle is the largest? The largest angle will be opposite 18 because it's the longest side. Similarly, the smallest angle will be opposite 7, which is the shortest side. Okay, now you ever don't want to say, oh, well, this one looks a little bit? No, don't do that. okay? Because they just told you that the largest angle is opposite the largest side. So here's 18, so that means the angle right across from here, this one would be the biggest, okay? That one would be your largest angle because it's directly across from the largest side. And then the same thing here, directly across from 7, this one is going to be the smallest because it's directly across from the smallest side, okay? And once we actually get into like figuring these out, it's very easy. This is not a hard lesson at all today. Okay, so here's comparing sides to angles and triangles. If one side of a triangle is longer than another side, then the angle opposite the longer side will always be larger than the angle opposite the shorter side. And now we have the converse of that, which means just turning the order of that around. If one angle in a triangle is larger than another angle in a triangle, then the side opposite the larger angle will be the longer than the side opposite the smaller angle. All right, now let's actually get into some shapes and numbers, and this will make more sense. Okay, let's take a look at example number 1. List the sides in order from shortest to longest. It's always a good idea to underline that or highlight that. That way you make sure you put them in the right order, okay? So what we're going to do is, first of all, we're going to take our knowledge of what we know about triangles, and we know that all 3 angles in a triangle add up to equal 180, okay? So we need to find this missing angle first. So you're going to add 86 plus 27. Yes, I know you use a calculator, okay? But that's going to give me 113. And then you take 180 and you subtract 113. And that leaves you with 67. So that means this angle is 67 degrees. Now that I know all 3 angles, I'm able to put the sides in order from shortest. So which angle is the smallest? 27. So the side directly across from that, AB, is going to be the shortest. Smallest angle, shortest side. So AB would come first. That's my shortest one. Now, go to the next the medium, which would be 67. 67, angle A, is directly across from BC. So that means BC would come next. And then the largest angle is 86, and the side directly across from that is AC. So AC is my longest side. All right, let's go to number 2. List the angles in order from largest to smallest. So I need to find my largest side. My largest side is 6. The angle directly across from that is A. So angle A would be the largest one. And then my next side that's would come next in order would be 5. And the angle directly across from that is B. So angle B would be next. And then my smallest side is 4. And the angle directly across from that is C. So that would come last. All right. Now we have the triangle inequality theorem. This is what this means, okay? And it's probably just easiest just to go through and show you. Can any 3 lengths make a triangle? The answer is no. For example, the lengths 1, 2, and 3 cannot make a triangle because 1 plus 2 equals 3. So they would all lie on the same line. This kind of just shows you what that means. The lengths 4, 5, and 10 also cannot make a triangle because 4 plus 5 equals 9, okay? And then it just tells you the arc marks show that these 2 sides would never meet, okay? So this is basically what they're saying. And this triangle inequality theorem helps you understand that. Any 2 sides of a triangle must have a sum greater than the 3rd side. In other words, sum means you're adding them. Okay, so what you do is you take a look at, sorry about that. Okay, So take a look at example 3. Do the lengths below make a triangle? Okay, well, here's how you look at that. You take your two smaller sides, here and here, okay? You're going to add them up. 4.1 plus 3.5. I guess I should write that here for people so they'll remember. 4.1 plus 3.5. And when you add those two together, you get 7.6, okay? So when you look at 7.6, compare these two to each other, okay? Now, is the sum greater than the third side? Is 7.6 greater than 7.5? Yes. So these three lengths, yes, they would make a triangle, okay? And that's all there is to it, you guys. 4 plus 4 is 8. So take a look at that. Compare it to that. Is it larger? No. So your answer is no. Okay? It can't be equal. It has to be larger. Okay? Go to the next one. 6 plus 7 is 13. Compare 13 to 8. Is it bigger? Yes. So yes, those three sides would make a triangle. And that's all there is to that, okay? So you add the first two sides, and the sum has to be bigger than the third side. If it's not, then your answer would be no, okay? So if it's equal to it or smaller, it's not going to make a triangle. Okay, number 4. Now, this one tells me to find the length of the third side of a triangle if the other two sides are 10 and 6. Now, this is when you have to think for just a minute and you have to say, okay, well, there's lots of different things that could go in there. How do I figure that? Okay, if the other two sides are 10 and 6, okay, well, this is how you do that. First of all, you subtract them. 10 minus 6 is 4. And then you add them. 10 plus 6 is 16. So you subtract them, you get 4. You add them, you get 16. And that gives you the range of where the third side could be, okay? So this is how you would write that. X, which is your third side, needs to be greater than 4, but less than 16. So this is how you would write the answer to that kind of a question. That way you're able to figure it out. So your sides are 10 and 6. Let's repeat what to do because they only give us one like this in our notes. So first you subtract them, get a number. You add them and get a number. And then you create your answer in a range that tells me that your third side is going to be bigger than 4, but less than 16. Okay, and that's the two numbers that you got when you subtracted them and added them. Okay, that's how you would work that kind of a problem. All right, let's take a look at the SAS, which is side angle side inequality theorem. The SAS theorem compares two triangles. We have two congruent triangles, triangle ABC and triangle DEF marked below. Now, they have their congruent markings, and you can tell side, angle, side, side, angle, side. Okay, so that's how we know that those two triangles are congruent. And so then it takes me through, and it says, therefore, if AB equals DE, okay, that's this side, okay, and BC equals EF, that's this side, BC, EF, okay, and angle B equals angle E, okay, then that means that AC, which is the other side, is also equal to DF, which we did learn that because we learned that once we are able to find a shortcut to say that these two triangles are congruent, then once we've established that, then the corresponding parts of congruent triangles are congruent. Okay, so that just means that once we've established it, that means angle A and angle D are going to work, angle C and angle F are going to work, angle AC and DF are going to be congruent. Okay, those would work. Okay, once you've established this, then all of the rest of them fall into place as well. Okay, so that tells us, here's our next question. Now, let's make the measure of angle B greater than the measure of angle E. Does that mean that AC is greater than DF? And if you take a look at the two triangles now, because we've made angle B larger than angle E, does that make this side larger than this side? And the answer to that is yes. And if you think about it, it makes sense, because remember, the side that's directly across from the larger angle is the larger side. So if this angle is bigger than this one, then this side is also going to be bigger than this side, okay? So it kind of goes along with that very first thing that we looked at. All right, so now we have that side angle side inequality theorem. If two sides of a triangle are congruent to two sides of another triangle, but the included angle of one triangle has a greater measure than the included angle of the other triangle, then the third side of the first triangle is longer than the third side of the second triangle. Okay, so we have the two congruent sides. Angle B, the first one, is bigger than angle E, which is the second one. So that means the third side is going to be larger than the third side of this one. Okay, so it kind of just repeats what it said up there, but it's in a theorem. All right, now let's take a look at example 5. It tells us to list the sides in order from least to greatest. All right, so the first thing you need to do is you have a missing angle here and you have a missing angle here. So what you need to do is you need to find those missing angles. So you're going to add 45 plus 92, and you get 137. So then take 180 and subtract 137, and that gives you 43. So this one would be 43, okay? And then you're going to add 68 plus 57. That'd be 125. And then you take 180 minus 125. And that gives you 55. So this angle is 55. Oops. Okay. So now they want you to list the sides in order from least to greatest. So find the smallest angle. Okay, I see 43 is small. And we're actually comparing them. And so if BD is going to be the smallest, well, I can tell by the congruent markings that BD is congruent to CE. So that one actually comes first, just because it's across from 43. So BD equals CE, okay? Now, let's go to the next one, which is, let's see, 45. So the side directly across from that is CD, okay? And then, let's see, go with the next one, which would be 55. Oh, no, I already did CE. Okay, so that means I go with 57. So the side directly across from 57 is going to be, oh, I already did CD. Oh, sheesh. Okay, so then go to the next one, which would be 68. And the side directly across from 68 is DE. Okay, and then that leaves me with the last side would be the one across from 92, which would be BC. Okay, you just need to remember least to greatest. Make sure you underline. For some of you, that might help to underline so you know which order to go in. Okay, and then just make sure that you find The smallest side is directly across from the smallest angle. And pay attention to your congruent markings also, okay? All right, next. Okay, the side-side-side inequality theorem tells you that if two sides of a triangle are congruent to two sides of another triangle, but the third side of the first triangle is longer than the third side of the second triangle, then the included angle of the first triangle is greater in measure than the included angle of the second triangle. That's a lot of words to just almost repeat what we just talked about. This is side, 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 okay? So in other words, if you have two congruent sides, okay, the included angle, that's the one that's between, is larger than this included angle. So that just lets you know that because this side is bigger than this side, that this angle is also bigger than this angle. So it can go both ways as far as which one would come first. Okay, let's take a look at example 6. If XM is a median, remember we did medians last lesson. If XM is the median of triangle XYZ and XY is greater than XZ. Okay, let's look at that. XY. This side is greater than XZ. So this one's bigger. This side is bigger than this side, okay? What can we say about the measure of angle 1 and angle 2? Well, if this one's bigger and this one's smaller, okay, what we know about angles, if this one's bigger, that means angle 1 is going to be bigger than angle 2. Because if this side's bigger and this side's smaller, that means this angle is also bigger and this angle is smaller, okay? And the way that you would simply write that out is you would write, that tells me that the measure of angle 1 is greater than, and yes, I'm doing a larger sign because I don't want somebody to get it confused with my angle sign, is greater than the measure of angle 2. Okay, example 7. List the sides of the two triangles in order from least to greatest. Okay, so here we go again with the sides, all right? We're going to need to find this missing angle, and we're going to need to find this missing angle. So go ahead and do that using your calculators. Add 44 plus 81, and then subtract that from 180, and you get 55, okay? And then you add 102 plus 36, and subtract that from 180, and that gives you 42. Eek. Don't give us much room, do they? All right, now we're going to list the sides in order from least to greatest. Least to greatest. Okay, so let's take a look at this. Let's find, since we're starting with least, let's find the smallest angle, which the smallest angle is going to be 36. So directly across from that is YZ. So YZ would be the smallest side, okay? Next, in order, looks like it would be 42. So the next one would be XY. Okay. And then my next one, let's see, YZ. And then XY. And let's see, I want to go in order. So then that means I'm going to go, 44 would come next, so that'd be XZ. Okay. And then next would come 55, so that would be WZ. And then next would come 81, so directly across from that is XW. And then the last one I have is 102, which is XZ, but I've already listed XZ, so I don't list it again. Okay, when you have two triangles that share a side like that, that's the way it would work. So since I've already listed XZ once, I do not list it again because we're just comparing the two triangles, okay? All right, let's go to example 8. Below is isosceles triangle ABC. List everything you can about the triangle and why. Okay, here we go. This is what I was talking about how they'll give you a question and they say, okay, what can you tell me? What do you know about those kind of things now that you've had other lessons? So you have to take a look at your congruent markings. You need to think about, what do I know about medians, all that kind of stuff. What do I know about what I just learned in this lesson? Okay, so let's just think about it here a minute. I know by these congruent markings that AB and CB are going to be congruent to each other. Okay, I know that much. Let's see if this angle here, let's see, is 61 and this one is 49. Okay, what does that tell you? Well, the side that's directly across from that, so this side is going to be bigger than this side, okay? Because I can tell that based on that. And then I also know, and this goes back, if these two sides are congruent to each other, that means this is an isosceles triangle, and that means my base angles are congruent to each other. So the two base angles are congruent to each other. So this is everything I know. I know, first of all, that AB is congruent to BC, okay, because of the congruent markings. I know that DC is greater than DA because of these angles, okay? And then the last thing, I know that angle A is congruent to angle C because they're base angles in an isosceles triangle. And I think, let me double check. Yep, that's it. All right, and that concludes our lesson.